In this lesson, we will use the DD utility to assess organizational security. We are in the DD portion of the video series, or more specifically, the digital forensics portion. This lesson is part of a video series that prepares you for the hands-on portion of the CompTIA Security Plus exam and is designed to give you hands-on experience with the exam. So what is DD? The DD command is used for copying and converting data, allowing users to create disk backups, clone drives, or convert data formats. It is used by system administrators and users who need to copy or clone data at the block level, often used in system backup or recovery tasks. The DD command is used when a user needs to perform low-level copying of data or make exact copies of storage devices, often in system maintenance, installation, or digital forensics and incident response situations. It is available on Unix-like operating systems like Linux and Mac OS. It is used for tasks requiring bit-for-bit copying like creating backups or cloning disks. The DD command is used via the terminal with options specifying the input file, the output file, block size, and other parameters to control the data transfer process. The rest of the how is what this video is all about, so let's get into it. To get started, grab the companion guide from the link in the description below. Also, if you like this content, please like, share, and subscribe to the channel so you won't miss any new videos. And we are back and ready to go. So we have our companion guide. So we have that on the left. We have Ubuntu on the right. And before we officially get started, let's talk a little bit about data states and tools. For example, we know that data has a couple of states, 3 to be specific in our case. We have data in transit, which is data moving across the network, and we use TCP dump as a packet capture to see that data going from one endpoint to another endpoint. We also used Wireshark, but TCP dump was used at the command line. We also have data in use. This is when data is processed in memory, and we can use a tool like memdump, which we will do in the next episode after this one. This episode is data at rest, data that sits on hard drives, databases, or other media, and we're going to use the data dump data capture utility, DD. Now, technically, DD is data description, but some people call it data dump or disk dump, so we're going to go through that process. What we're going to do is we're going to look at bit-by-bit copying of disks using the DD utility. We'll create and verify a forensic image that we can test offline for looking for embedded files, and then we'll make sure that we have hashing for integrity. If you're not familiar with some of these concepts or tools, please look in the video library for video tutorials that discuss this topic. So let's go ahead and check the directory disk space before we go into this. So I'm going to open a terminal session. I'm just going to open it from the right side here by right-clicking the desktop. I maximize this. I'm going to increase the command line by 2 lines here, or 2 prompts using the Control++. And while I'm at it, I'm just going to switch over to the downloads directory. So I'm going to the downloads directory, and I see that it's pretty clear. I do a print working directory, a present working directory to show my path, and I'm all set. Now I'm going to use the DU home, and I'm just going to check the directory usage style. So DU is for directory usage. It goes in, it shows me I have about 5.3 gigabytes, but this doesn't help me too much, right? So let's get this on the top, and I'm going to throw a flag on this, which is make it human readable. So I'm going to say make it human readable, and we see that it is 5.2. This also gives me a play-by-play of all of the folders or the size of the home directory, but maybe I just want a summary. So we're going to use the DH command, or DU command, I should say. I'm going to use in the home, and I'm going to do a summary and human readable. And I hit enter, and it tells me my home directory is 5.2 gigabytes. And that's what these 2 commands did. I summarized the total so that way we get the bottom line, and we made it human readable. Now we can also do this at the root directory. I'm at the home directory. Let's say we wanted to get a sense of the whole drive. So I can do a directory usage. I'm going to keep it human readable, And this time I'm going to slash, which is the root folder, and it's going to go and attempt to get a summary of all of that information. Now, because it wasn't sudo, there are some folders that it can't read, but it's going to attempt to give us a complete readout. So after 5 seconds or so, it shows me that it's at 23 gigabytes. I'm okay with that. I could have just done a summary on that, so I'm going to clear, and we are in pretty good shape here with directory usage. Let's go ahead and take a look at disk free. This is the df command, and we're going to make it human readable, and I'm going to do disk free, and it's going to give me a sense of my disk, what's free and what's available. So we just did the root. We see the root drive, which is dev SDA. This is a 34 gig hard drive. 18 gigabytes of it has been in use, 15 is free, so about 57% of it's been used, and we get a quick synopsis of our hard drive. Now in the field, we would try and clone this whole hard drive so we could analyze it, but we wanted to get a sense of what this looks like beforehand. Now, if you want to see this from a graphical perspective, because sometimes seeing this in a graphical, I'm going to try and install sudo install baobab. It's going to prompt me for my sudo command, super user do, because I'm elevating the privileges. It's going to read the package, and it says I already have it installed, which I knew that already. I'm just putting that in here just in case you didn't and you know how to install it. And I'm going to run baobab. And baobab is a graphical utility that's going to do similar to what we have done here before. So here's my home folder, and over here is giving me a graphical layout of my home drive, and it shows me that it is 5.5 gigabytes. I knew that because I used either the disk free or the disk usage du commands, but also I can get this from a graphical perspective as well. Okay, so just wanted to quickly highlight how to actually see the data on the hard drive, and we're actually going to get into the data description or the dd command. So I don't need the graphical user interface anymore. I'm going to close that out, and let's just analyze the format of the file. So the file is dd is the command. The input file, if, is going to be the input file that we're going to essentially copy or manipulate. We're going to output that to an OF file, and then we have options, different options like block size. We can do the count of the block size. We can also use the status to show our progress. So in this case here, we're going to just test disk performance. We already saw the df command -h. It gives us the usage. I'm going to copy this file over here. You can type it if you like. For the purpose of a class, I'm going to spare us and just type it in, and let's analyze this again. So dd is the command. The input file is dev0. This is a series of empty blocks or data. The output file is going to be a test file, and the block size is 1 megabyte. And blocks or the disks are very similar to seats in a stadium, and we're going to say the seat in this particular stadium is 1 megabyte. And we're going to do this 10 times. In other words, this is going to be a 10 megabyte file, and we want to see the status in progress. I hit enter. It made it already. It quickly completed the file. It says 10 records in, 10 records out. We have our 10 megabit file. Let's go ahead and do an ls -lh, which is listed human readable. I'm going to do test file, and here's our 10 megabyte file. We know that our command is looking pretty good. Now, before we actually go in and work on the data, in the real world, what we probably would do would use a write blocker. Now, a write blocker is a device that's going to make sure that we do not tamper or have any challenges or problems with the original data. Now, I'm just showing this on an Amazon simply because of the pictures, what a write blocker looks like. So this is a USB drive. It's connected to the write blocker. This would be connected to our forensics computer, like our laptop. This is the actual device itself. This here makes sure that when we're copying the data, we are not tampering or changing the data, because it is, in some cases, a criminal scene, and we want to make sure that we have maintained the chain of custody, and we, in the analysis process, have not tampered with the evidence. It's very similar with a crime scene where you see that the investigators are wearing gloves. They're making sure that they're not tampering with the evidence. So a write blocker is going to preserve the evidence integrity, make sure that we do not make any changes. We also make sure that we do not change the timestamps or metadata, who's the owner, if the file was last modified, and also if this data or this drive needs to be presented in court, we want to maintain the proper chain of custody. So for the rest of this exercise, we're going to simulate this process so you can get a good hand of it. And we're going to create our own suspect drive using the DD command. So I'm taking the DD command, bring it over into the Ubuntu Linux, and same concept here. We're going to DD, the input file is going to be a bunch of empty data. We're going to output it into a file called suspect_drive.img, which is an image file or a hard drive file. The block size is 1 megabyte, and we're going to do this 100 times. In other words, we want a 100 megabyte file. I hit enter, it has created it. Let's go ahead and take a look at that file and see that it is indeed there. So we have our test file, which is 10 megabytes. We have our 100 megabyte file. Okay, so we're building our virtual drive, if you will, our virtual hard drive, and we're going to put some data into it. We're going to copy confidential data. We're just putting some text into this drive. So let's see what that looks like. I'm going to copy it from our companion guide, copy it into clipboard, paste it into the command line. So we're going to echo confidential data dash forensic investigation. We're using the pipe command. And we're going to send this to the DD command, and the output file is going to be suspect.drive that we just created. The block size is 1 megabyte, and we're seeking 1, meaning that we're going to the 1 megabyte file in that stadium. So seat number 1, if you will, and we're saying do not truncate the file. In other words, keep the rest of the file the same. So we're inserting this text into seat number 1, or 1 megabyte into the document. We hit enter, it gave us a problem. Let's see what the problem is. And the conversion issue is the trunk. I didn't copy that properly, so we say no trunk. We hit enter, it looks good, and we know that it's fine. Let's go ahead just to be sure that we did not transfer or alter that file size, and we see it's still 100 megabytes. Okay, so that's good here. Now, we're also going to insert a file. We're going to download the bridge.jpg. So you can go to the companion guides. There's a link here. The companion guide will have it as well. But if you want to, you can go to bridge.jpg on the downloads page of the link. This links to it. I'm going to download it right into Kali Linux. So I clicked on the file, and it's a picture of a bridge. Great. I'm going to download this into our downloads folder. My browser is set to automatically download files to the downloads folder. And let's go ahead into the command line and see if that's true. So I'm going to do an ls, and I have my bridge.jpg. Now, as we mentioned in class, if we really want to be secure about this, anytime we introduce a file into our system, we want to make sure that it hasn't been tampered in flight, either through data corruption or an adversary in the middle has altered that file. So we have a hash value that we can verify this. It's also on the website. So if I was to close this out, we see we have our MD5, which is in this case here, it's alpha 4614989. So let's go ahead and verify that so we can make sure that looks good. So I'm going to clear the screen to give us a little bit more space. I'm going to MD5 because that's what the hash value is. It's MD5 and sum. And we're going to look at the bridge file, and it gave me the hash. And at this point, it's fine. I can go ahead and compare this number for number. But as you know, we can pipe this to a file called, let's say, hash, whatever we like, hash.txt. And then we can use the MD5 sum minus check command, and it's going to make sure that the hash value to the bridge.jpg or JPEG matches, and I get the OK symbol. So it's okay to continue working with this file because now we know that its hash digest or its message digest matches the one that was published. So we're okay with that. So with that said, we're going back to the DD command, and we're going to insert this bridge file, this JPEG, into our suspect drive. So let's look at our command. DD if equals bridge, which is a copy of this JPEG. The output file will be the suspect drive file that we created a few steps before. The block size will be 1 megabyte, and seek 10 means that we're going 10 megabytes into the offset into the file. In this case here, for argument's sake, we're going into seat number 10, and we're not going to truncate the file. Okay, so this looks good. We'll also do our ls, long and human readable, so we can see the information here, and our suspect drive has not changed. So we've made two changes so far. The first one was we inserted in seat number 1 confidential data into this file. And now in seat number 10, if you will, or in this case here, this was seek 1. This one was 1 megabyte. So we put this into that spot there in the bridge, and we just checked it, and it all looks fine. Okay. So we're going to do this one more time. We're going to compress the bridge file because we want to conserve space. So we're going to use the zip command. Zip is a compression utility. I'm going to bring that over. I copied it from the companion guide, copy Control-Shift-V into the Ubuntu, and I'm going to zip into a file called hidden.zip, and we're going to bring in the bridge.jpg, the JPEG file. Now it has added this file, created a zip file, added the image into the file, and there wasn't a whole lot of compression with this file. So it says deflated 0%. There wasn't a lot to deflate because the file was relatively small anyway. So I'm going to do an ls, and I see my hidden.zip. If I do an ls minus long, we can see all the files in our downloads directory. We have our bridge file, we have our hash.txt, which we've done, but more importantly, we have our hidden.zip, which is what we just created here. So we're all set. Now, one more, we're going to actually now embed the hidden.zip into the suspect drive using the DD command. So we're taking the zip drive, and I'm going to take this command, copy and paste it, bring it in, or you can type it if you like. I'm just trying to save time for the purpose of the tutorial. We're going to DD. The input file is going to be the hidden.zip that we just created, which has the bridge.jpg file. The output file is the suspect drive that we created. And then we're saying the block size is 1 megabyte. Once again, this is like a seat in a stadium. We're saying it's going to be the size of the seat is 1 megabyte. And we're going to seek now in position 20. So Echo Confidential went to seat number 1. Our bridge went into seat number 10. Seek is going into seat number 20, this hidden.zip. So we don't want to truncate. We hit enter. It tells us the record's in, record's out. It gives us some output because that's what we asked. And now we're going to ls just to make sure that our file has not changed. It is not in human readable format. So let's go ahead and add the flag, the H flag, make it human readable, and we still maintained 100 megabyte of file size throughout this process. So we're looking good here. Okay. So now we have our drive. I'm doing a little housekeeping on the left side here. I'm going to clear, and we're just going to ls the suspect drive just to get a better handle on it, just so we can see it. We're going to do long and human readable, and we have our suspect drive. Now this is where the forensics actually happens. And once again, if we were actually coming into an incident response and analyzing this drive, we would connect it to a write blocker. And there's different ways we can connect this with this device. Again, this is not a PSA to purchase this one, just giving you a visual representation of what a write blocker looks like. And we have our laptop or our forensics device connected on the other side. What this will do is make sure that it is read-only. That way we're not tampering with the evidence. It's like putting on the gloves, making sure we keep the chain of custody and the crime scene sanitized. And now we're going to make a copy of this drive so we can analyze it using the DD command. So a little bit of housekeeping here first. I'm going to take the DD command, move the DD command over into Ubuntu. Let's analyze this. We're going to DD. If suspect, the input file is suspect_drive with all the work that we have done. The output file is going to be a forensic copy. The block size is going to be a little bit bigger here. We want 4 megabytes. We want to make sure we have enough space. Status equals progress. And this is going to be a bit-by-bit copy. It has worked perfectly. We're going to do a quick ls to see if we have a copy of the forensic. And now we want to make sure that the hash is the same. In other words, we want to make sure that the file, the suspect file, and the forensic_copy are exactly the same. And this is important if we want to prove that we didn't alter the file during the copy process. So we're going to use SHA. We could use different ones, but we're going to use the SHA sum. So I'm going to use SHA 256 sum, and I'm going to compare the suspect drive to the forensic copy drive that we just created and compare the hashes on screen. And I see that they are identical. We can do a diff if we wanted to, but for the sake of the tutorial, this is lining up properly. And now from this point on, we're going to do our work on forensic copy. We're leaving the original as is. We know we're working with an exact replica. And now we're going to do our work off of forensic_copy.img. So our hashing is fine. Now let's go ahead and use the strings command. I'm going to clear. And the strings command is going to just give us readable, printable text from binary files. I'm not going to throw any flags in there, so strings. And let's see, what do we have? And it's going to give us a bunch of what appears to be regular human readable text, if it is human readable. And we're just going to do a quick scan. And at this point, we would be looking for some content. Now, in this case here, I'm going to clear the screen to get us back on top. Now, we're looking for something specific because we have a little bit of intel. My caps locks were on. We know we're going back to the top here. We're looking for anything in this particular line. We're looking for confidential data, forensic investigation. So if we have partial information because we know what we're looking for, we can use the strings command, combine that with grep, and we're looking for any hit or match that has confidential in it. So we're going to use the strings. It's going to give us printable text from a binary file, which is what the IMG file is. It's bit by bit. We're looking at the forensic copy because we made a copy of the suspect drive, and we're grepping for confidential. And let's see what happens. And we have our data. We see the full line here. And we know it's there because well, we put it, but now we know it's there because we used the strings command. Now, we can also use a binary walk, a bin walk, where we can use this tool for looking at embedded files in binary images, which is what forensic_copy is. So let's go ahead and just do binary or bin walk just regularly on the forensic copy file. So we'll do a bin walk. And bin walk is going to do an output for us of the decimal, hexadecimal, and it says here we are in position 10, or 10 megabytes, if you will. There's a JPEG file in here, and it says in seek 20, in 20 megabytes in, we have a zip archive data. So this is the hidden.zip that we pumped into a zip file, and then we compressed it and we inserted it into the subject or the suspect_drive, which we made a copy of, and we're analyzing forensics, and it gave us our information here. So we know we have embedded data in this IMG file. We're going to use the binwalk -e command to extract that file. So first, let me copy this. I want to show you something here in a moment. I'm going to do an ls -long to show what the folder looks like before we run this command. Then I'm going to use binary walk, and we're going to extract any embedded images in here. So the -e is going to extract any found files. We'll hit enter, allow it to do its work, and give it a couple of seconds or minutes. Okay, so that took about a minute, and what happened is that it has now extracted certain files. Now, give us a little bit of a warning here we're going to take a look at, but I want you to see before we ran the command, this is what the folder looks like, the downloads folder. I'm going to do an ls, and now we have this new folder, forensic copy.img extracted. So the -e extracted all of the files that it found in the forensic file. So let's go ahead and cd to that. We're going to cd to _forensic, and we're in there. We'll do an ls, and I see I have two files. I'm going to clear to bring that up so we can do this at the top of the screen. And I have two files. This is the zip file, the hidden.zip, and this is the bridge file that we have in here. So I want to see the bridge file just to make sure. So the way I can do that is I just cd or change directory into that file, and I'm going to install a image manipulator, or basically a photo, which is called GIMP. So I'm going to sudo apt install GIMP. I already have it installed, but this is just in case if you are working on your own version of Ubuntu, you want to see I already have it. So that means I can run the graphic or the GNU image manipulation program, and I'm just going to call the file properly. So it's bridge.jpg, and this is in the extracted folder, and sure enough, we now have that file. This file was extracted from our forensic copy. Okay, so this is looking really good. There's another tool we could use in digital forensics and incident response as it relates to the DD command. So we're looking at Foremost. Foremost is going to extract hidden files also. So I'm going to cd and ... just to go back one level, do an ls. I'm going to do an ls -long so we can see the file. And now you may or may not have Foremost installed. And the reason why we're going through this here is while we are discussing the DD command, we are in the forensics portion of the class, and there's a series of tools that we will stay here, DDs being the first that we're introducing, but there are others, as you can see here, bin walk, strings, and Foremost. So we have Foremost. It was already installed, so that means I can actually run Foremost and analyze or extract files. So let's clear the screen, bring in the command, and the command was put in. I'm letting it work, but let's take a look at the structure of this. -v means that it was verbose. The input file is the forensic _copy.img, which is the directory or the image file that we created from suspect, and we're analyzing it, and it's doing the output to the output folder. So all of this is in the output folder. It extracted the files automatically. So rather than do bin walk, we can use Foremost. I'm going to do an ls, and I see I have a folder called output. I'm going to cd to output, do an ls, and look, I have a JPEG and a zip file, a compressed file. So let's clear and do this again from the top. I'm going to do an ls. First, let's cat the audit.txt. It gave me some information, so it told me what file and the command that I used. We just analyzed it. This is the home directory. This is the conf file. If we need to make some configurations, we'll deal with this a little bit later. But most important, it's telling us in seat 10 megabytes in, the file offset, there's a JPEG file in there. We happen to know it's bridge because we put it there. Also, the file offset, 20 megabytes in, there's a zip file. Hidden.zip is what we put in there. It extracted all of those files and it put them into the output folder using Foremost. I do an ls on this here, and then I can cd into, I know it's a folder because it's in blue. I'm going to cd to the JPEG folder. I do an ls. I have this file here. It's not named bridge. It was renamed. Let's use GIMP to go in there and open this file and see what happens. And it's a copy of our bridge file or our bridge photo. So this is fantastic. We looked at a couple of things here. We looked at bin walk, a binary walk to extract images. We also looked at foremost to do the same. So I'm going to just do a quick highlight on this here and round this up with memory. So we can go ahead and look at the memory using a hexadecimal low-level analysis dump. I'm going to clear the screen to get us on top here. I'm going to cd ... I could do it a couple of ways in ... just to go up. I could have combined the commands. I'm in ls. It was just quicker for me to do it this way. And what we're going to do is xxd is a hexadecimal, and we're actually not going to do it on the suspect drive. We're going to do it on the forensic copy because I want to look at it from the forensic copy side of view. And it's going to give me the full memory dump and the location of those files so we can analyze them. But speaking of memory dump, that's going to be the next class, which is looking at data in use, and you can see some of it coming in here. I just wanted to introduce it here that we can use it on an image file as well. So with that said, we're getting towards the end of this particular tutorial. I'll stop the memory dump or the hex dump where you see this here. We'll pick this up on the mem dump side or the memory dump side of it, or the data in use when data isn't actually in memory. But back to our DD command. Our DD command, if we want to get more help on this here, I can clear the screen here. I can DD tac help, and it's going to give me a number of options here. We're going to, as you know, we say this quite often, this is just the tip of the iceberg. You can explore this a little bit more deeper with the help command. I'll clear this here. You can also use the manual command. We could use man dd, and it's going to launch the manual command. But the purpose of this tutorial was to review data in transit that we have already done with TCP dump. Data at rest is what we just did here with disk dump, specifically data description. And now we're going to move on to memory dump, data in use. I sincerely hope you enjoyed this lesson, this session, this tutorial. I enjoyed creating it and delivering it, and I look forward to seeing you in the next one. See you soon.